Hello everyone and welcome to another video here on the School of Quantum of the Hidden Quantum Champion series. Today we are looking at a company called Attocube, and if you want to know what they're actually doing, if you are curious about the atomic scale that they are delivering to the quantum technology stack, then stay tuned for today's video and not miss out on this episode. And with that, let's hop right into their website. So here we are. It says Attocube Wittgenstein Group up here. And here you see basically something scrolling through. So it says game changer in magnetic imaging. Doesn't sound super quantum, right? Well, I mean, if you're looking down here, you see NV microscope. So there you can already infer that this is using quantum technology, right? We've had some previous company already highlighted on this. And is using NV microscopy. So in this case, I think it's Sabra here, which is mentioned as a technology partner. And this is a pure quantum invention, or this is also part of this second quantum revolution, because this is using a quantum sensor, an NV sensor, to measure magnetic properties. But there's also vibrational analysis, which you might not consider super important, semiconductor equipment. So maybe also not super quantum, right? There's also something here on the cryogenic components, something here on 3D fields from a 2D vector magnet, so magnet production. But you can also see they are, let's say, active in this quantum sphere. So here it says, let's celebrate quantum, the International Year of Quantum Science and Technology, which is 2025. And then find out why Attocube is the engine room of quantum innovation. And I think that is definitely something that we should check out in a second. But quickly going through those other ones. So here it says something about open cavity based kit. So this is also in the optics range. We see here some nanoscopy solutions. So nano kind of microscopy, so like height profiling or something like that, diffraction limit, breaking the diffraction limit. Then I guess Raman kind of spectroscopy, which is also a physics method that is being used throughout, let's say, nanofabrication, nanomanufacturing. So you see that they are very active in this nanoscopic area where it's like about microscopes and analytics tools for example, semiconductor industry that is working in these ranges. But let's quickly also hop into that one here to see how they are actually active in the quantum space. So enabling the quantum revolution. The future is quantum. Read how Attocube is enabling key players to scale up quantum technology. Explore how cutting-edge partnerships are accelerating the quantum technology revolution through two insightful editorials that spotlight Attocube's pivotal role in advancing the quantum supply chain. Discover how Attocube is engaging a new generation of industry end users while continuing to serve the scientific community, enabling applied R&D and fostering technology innovation across the quantum landscape. Learn how Sparrow Quantum, which we highlighted before in this series, a leader in single photon and entanglement sources, relies on Attocube's enabling technologies to transform advanced research into scalable products for quantum computing, metrology, and early-stage quantum networks. Together, these stories illustrate the synergy between innovative research and industrial application, showcasing how technology partnerships are shaping the future of quantum computing photonics. And I don't want to go into the details here, but Sparrow Quantum, if you don't know about them, go check out the playlist on the Hidden Quantum Champions. There you can find more about them. And then Attocube, we see it down here, is a company based in Germany. Now, quickly, a little bit more on the quantum technology side of things. So here is also something, it says OEM solutions, custom engineering, manufacturing, and integration. And I think that one also highlights the role that Attocube is playing in this quantum technology space. So here it says industrial cryogenics and precision components for quantum photonics. And cryogenics, we know they play an important role in order to observe the quantum properties of a system, you need to remove all the thermal noise. So you need to cool down the system to these cryogenic temperatures. This is not only true for superconducting circuits like the ones that we know from these chandeliers, for example, at Google or IBM. This is also true for the gas-based ones, where usually, if you, for example, look at ion quantum computers, you also have to remove the ions that have a high thermal energy, and you use laser cooling techniques to cool them down. So cryogenics, of course, on the solid state side, as it refers to here, but also the, let's say, ions, neutral atoms, they are also at a cryogenic level. Cryogenics plays a very important role in quantum technology. And then we see here precision components, and that's something that is also interesting, and we will I guess learn about in a second. So the last years, and now back to the text, right? The last years have seen a steady surge in worldwide quantum funding. This results in a whole new, fast evolving industry with first commercial applications in quantum computing. All these approaches hold the promise to solve computing tasks that are virtually impossible to solve by classical processors, and offer ambitious solutions for the so-called quantum communication area. The latter could pave the way towards a quantum internet based on inherently uncrackable security. The core of all these technologies is constituted by quantum states and processes such as a single photon source, trapped ions, or superconducting or photonic qubits. In order to maintain their quantum nature, these delicate states mostly require cryogenic environments, low vibrations, as well as high vacuum. So, agreed, all of these things are true. By the way, high vacuum is also in a way correlated with cryogenic state, because if you cool something very, very far down, then basically all the gas will just freeze and you end up with a high vacuum. But that's just as a side note. Mechanical, electrical, and optical components have to be positioned with highest precision in these extreme environments, and costly system failure must be prevented by extensive pretesting. Attocube offers world-leading low vibration and unique compact rack cryostats, as well as high-precision components to align, operate, and test such advanced quantum systems. And I mean, positioning something, you might think of your servo motor, servo engine that you have at home from your playing around with electronics stuff, but this is really like a different level here, because we are not only talking about positioning something at a very, very, let's say, small range, like moving something in a micrometer range, but also at a cryogenic level, right? So at very, very cold temperatures, where you really have to make sure that like everything that you're putting down there is not kind of freezing, not changing its properties when you cool it down. So this is very specific and very complex to manufacture equipment. So you really need some expertise, and that's where Attocube comes in. Now, where do their components actually play a role? So here it says high precision components for single photon sources. So cryogenic cooling for industrialized brilliant light sources for quantum computing and quantum information processing. Then cryogenic probing for PICs, so sophisticated platforms for alignment of optical fiber probes and testing of photonic integrated circuits and quantum computing chips. And then testing of quantum computing components, so analysis of mechanical, electrical, and optical properties of quantum components before integration into quantum computer systems. And that's related to what we've seen before, like the Raman type of spectroscopy, the microscopes that are being used to kind of probe these very tiny samples before they are actually being manufactured into the full chip. And yeah, there are also some partners linked down here. There are the products that they have. So again, they have cryostats, there are some microscopes. On top of that, there are some measurement tools, so measurement options for material characterization at low temperature and in high magnetic fields. We also saw there was something about magnets before, which can create a very different specific magnetic field conditions. There's nano positioners, that is what we've talked about before, right? So they are being used to manipulate fiber positions, to manipulate photonic circuits positions, to move the chip back and forth in these cryogenic conditions using piezo crystals. And then there's displacement sensor, modular laser interferometer for measuring displacement in the nanometer range, contactless and under extreme environments. So I guess that's like it's an interferometer. So it uses the light's property, the interference of light, to measure the distance of something. Kind of, let's say, the supercharged version of this thing that you're using to measure how big your room is. There's this tool which you can point off, like you put it on the wall, you press on the button, and then it shoots a laser, and it uses interference of this laser beam to measure the distance, like to the next wall. This is kind of, I guess, the supercharged version for scientific applications with much higher resolution. And then, here the application. So as mentioned before, they are very much catering the scientific market up to now, but also spinning out of the scientific market the quantum industry, right? So you see here like accelerators and scientific analytics tools. Precision engineering is though already, let's say, on the market side, and that's also something that they are catering. And then down here, you also see something about the exhibitions. I'm recording this video mid of December 2025, and you see here that there's another one coming up in Grenoble in France, and there's already one for next year announced. So that's very much up to date down here. And then on top of that, it says also advancing technology standards in industry and research since 2001, so 24 years, almost 25. So there will hopefully be a nice celebration very soon for the 25 years anniversary of Attocube. So since 2001, Attocube has been at the forefront of applied nanoscience, delivering unique and innovative products to customers all over the world. Our compassion is to redefine precision and create products that work at every edge of technical and physical feasibility. High-level scientific publications have been produced based on Attocube's products. Several Nobel Prize winners work with our solutions, and industry customers work a wide range of sectors rely on our profound knowledge and experience of working in the smallest of dimensions. The expertise and motivation of our team guarantee top quality consulting, and we offer a comprehensive on-site installation service and professional after-sales support. We are advancing technology standards in industry and research, which is why the world's leading scientists and innovators trust Attocube's products. And then here we see some statements, some quotes from, for example, Harvard University, Department of Physics of Cambridge in the UK, Munich, Ludwig Maximilians Universität, but also Grenoble, some French institutions. There's more French institutions, more US, ETH in Switzerland. So you see there are a lot, Russia as well. So there are like international, a lot of institutions, Germany, Italy as well. So many institutions, Spain, that are using this technology, and I can attest to that. So in the research center that I used to work in, there were also some equipments from Attocube, and that's of course also why they are featured in the series, because I can say as a researcher I've been in touch with those products, and I can say that they do play an important role in what we are developing or what is being developed in the world of quantum technology. Of course, there's much more to learn here. So there are like more information on the cryostats, on the microscopes, the measurement tools, nanopositioners, displacement sensors. There are also information here on the business sectors and the applications that they're active in. OEM, we've seen the quantum technology part here with the different photonic applications on the top level. But of course, there are also additional resources like webinars, brochures, and whatever you can get from a sophisticated company like this one. We will move towards the end of this, but before, as per usual, we are taking a quick look at the about page of the company. So it says, this is Attocube, explore the smallest dimension. We see this very nice and white building here. It says, Attocube is a leading pioneer of nanotechnology solutions in industry and research. The company develops, produces, and distributes components and systems for nanoscale applications such as precision motion, cryogenic microscopy, and nanoscale analytics. All products are manufactured in the Nanofactory, the company's headquarters in Haar, close to Munich. An international team of 240 physicists, engineers, software developers, and product designers work in close collaboration from conception through to delivery. Attocube has sales offices in the US and a broad network of worldwide distributors covering more than 40 countries and 4,000 customers. The company was founded in 2001 as a spin-off of the CENS Center for Nanoscience at the LMU University in Munich. Professor Dr. Khaled Karay, I hope I don't pronounce that completely wrong, and his PhD student Dirk Haft, two visionaries with expectational entrepreneurship spirit and courage, developed a nano-positioning device that could function under extreme conditions such as cryogenic temperatures, ultra-high vacuum, and magnetic fields. This idea won them the Munich Business Plan competition, which was the springboard for the future of Attocube. What began as a two-man show with a large portion of creative playfulness, passion, and the input from some experienced advisors continued to grow. The company has since gone on to win further prestigious awards, sustainability, broaden its portfolio, and hired additional employees. Today, Attocube is a global player in the field of nanoscale applications, delivering its products not only to world-renowned research institutions, but also serving customers in future industries such as semiconductor and quantum technologies. One thing, however, has remained untouched until this day. The team has retained its Attocube DNA, from the light and transparency of the Nanofactory's architecture to the bold, passionate, and sometimes even unconventional way that Attocube employees inhabit their work. To put it simply, the Attocube spirit remains. And then here are the facts and figures, starting with the basically 1995 even submits where the first patent was submitted, then 2001 when the company was founded, all the way to 2023 opening of the Atto base, a 1,200 square meter additional space for logistics, production, and testing. That is only 2 years ago. So 1,200 meter square production space, 4,000 customers, we've seen that before, about 60 trade shows that they're visiting every year, and 18 different nationalities. Here you see the huge number of awards that they've been winning, certifications, various types of ISO certifications that they have. The mission is, at Attocube, we enable scientific and technological progress in applied nanoscience. The vision is, our passion for precision drives us to revolutionize nanoscale motion and analytics. Our reliable and intuitive systems make us the first choice for customers in science and industry. And then here we see the two founders. With that, I think we have seen a lot of different things about the company. Definitely, from my point of view, a company to check out, and definitely one that counts into the hidden champions, because it might not be the first one that you're looking at when you're thinking about shiny quantum computing chandeliers, but definitely one that plays a very big role, not only in the development, but then also in the execution, especially as we saw on the light part of quantum technology, quantum communication. If you like that video, make sure to give it a thumbs up. If you have any questions or any other companies that you want me to check out, then let me know down in the comments below. I'm looking forward to see you back to the next video. Until then, make sure to stay hydrated and see you soon. Bye bye.